Hey folks, can everybody see and hear me? Alright, good deal. So today, we're not doing the whole Space Invaders thing like we did last week, but we will be doing something very similar, except with the Asteroids game that's included on the Raspberry Pi. Um, it's a little bit easier than the Space Invaders game, so it shouldn't take us, should probably only take us one class, so um, hopefully also you have your pies and will get them set up. And hopefully also you have your joystick and or button, because we will be working with that with this game today. So what I'm going to do, I'm going to put hands down, just like it has been for the past week. If you are able to get your Raspberry Pi set up, go ahead and do so, and then raise your hand. If you are not able to get your Raspberry Pi set up, no chance of getting it set up, then also raise your hand, just so I know when we can continue on to the lecture here. So the question, when you try to open Space Invaders over the weekend, it wouldn't open, and now you think it got deleted somehow on your Pi. Huh, that's weird. That could be the case. Um, what I can probably do is either me or Mr. D or whoever you have a lab with um, can just load the unaltered file and give it to you at the lab, whenever that may be. So don't worry, we're not going to be working this weekend. Alright, I'll go ahead and email Mr. D about that then, so he can put it on a flash drive for you, so you can put it onto your Pi. Luckily, we won't be messing with the, let me write that down actually. We won't be messing with the Space Invaders game today. We might a little bit, but it won't be too crazy. Hopefully Asteroids still works though. So if you're just getting on, we're getting our pies ready and raising our hand, or we are unable to get our pies ready and therefore we also raise our hand. Alright, so we're looking pretty good here. So obviously, if you haven't guessed by everything I've said, we're going to be working with Asteroids today, so not Space Invaders. We did pretty much go over everything Space Invaders has to offer, minus a few things, but anyways, we'll just continue on with Asteroids. Last week we did focus on that Space Invaders, and our ultimate goal was to become confident in understanding the code, so we can change it to become easier or more complex, have physical inputs, which we didn't talk much about that last week, but we will today with the Asteroids game. And also we're able to customize it to our needs, so if you wanted to, you can change your invader sprites to whatever sprites that you want, honestly. And that basically goes with any Scratch game, so I hope that you've had a little bit of fun with Space Invaders so far. But we're going to do that with Asteroids today, and like I said, hopefully you do have a joystick and the button that we gave you. If not, it's okay. Just beware when you watch the webinar that you'll need to connect everything correctly and yada 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 yada. And I do see a question. You have two buttons. And yeah, that's fine. No big deal there. You only need one. If you have to, you can always make a new broadcast that'll say when the green button is, or the green flag is clicked, then initialize your GPIO. Basically, I'll talk more about that a little bit later. You only need one for today, but we did give you two. So if you haven't already, I do want to give you the opportunity to sort of experience what the game of Asteroids is like. Just want you to sort of familiarize yourself with the mechanics of the game so you understand exactly what's going on. And like I said, it's a lot easier than Space Invaders. So go ahead, if you can, open her on up. Um, Basically, the controls are left, right, and up. Left and right will turn your ship, up will make you move, and spacebar is fire. So go ahead and do that real quick, just so you sort of know what's going on. And raise your hand once you've done so. And I'm not rushing you or anything, I'm just saying. There's no hurry today. Pretty day outside, life is good. Hope you all had a great weekend. I sure did. I'm still not entirely sure if we're going to be working with the Pac-Man code, because it is by far the most complex of the games that are that come bundled with the Pi. We might, but I'm not entirely sure if we will or not. And if you're just now showing up, we're going to be working with the Asteroids game on our Raspberry Pi. Going to do something similar to what we did last week. But if you have your joystick and a button, we're going to be hopefully get to that today. So let's see where we're at here. Alright. So I guess I'm going to go ahead and continue on with the lesson today. Where we're going to start is with our ship. So, unlike with Space Invaders, we don't have to keep track of all those weird broadcasts that each do something different, each on different sprites. There's a couple broadcasts in this game, and that's okay, but it's nothing like last week. There's just 3, I think. So it's not like we have to have a whole flowchart with, 20 different pieces to assemble. So life will be good today. Life will be nice and easy. So just like before, we're going to initialize this code when our green flag is clicked, keeping everything within a forever loop so that any time that that flag is clicked, we're going to be able to reinitialize our game. So this shouldn't look anything new to you all. It's going to switch to a certain costume. This time it's the default costume called Ship. There's 8 other costumes for it, which we'll talk about later. We're going to set an initial position, set an initial forward speed to be 0, and we'll talk more about speed in just a little bit because it works differently than it did in Space Invaders. Set our lives to 3, surprise, surprise. Our initial score to 0, and we're going to set our hit boolean variable to 0, or false, or not hit. That'll be used in just a second, actually, to augment our movement, among other things. And you'll see that throughout our code for today. So the code then gives the ship some motion, and this is where we're going to be adding the joystick into later. If you did do some of the joystick stuff in lab, this will probably look pretty similar, but notice also that it doesn't have the same behavior when you do click these arrows. But basically the loop that all this stuff is in makes sure that our ship will move until we do run out of lives. So it's just going to keep on running over and over and over and blah, 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 until we're dead, of course. So I do see a question here. Will we be using the joysticks today? If we have time at the end, which I do think we will, I'll start talking about coding the joystick. If you don't have your joystick today, though, that's okay. Remember, we'll always have the YouTube videos that you can look at. You can connect it later. But yeah, that's what I'm trying to get to today. We'll see, though. If you don't have it, it's fine. So if the ship has not been hit, remember hit being a Boolean, our left arrow is going to turn our ship 15 degrees counterclockwise, and so similarly with the right arrow being pressed to turn it normal clockwise. So a little bit different, we just have that extra degree of movement, which comes with the up arrow key being pressed. So that's going to be nice when we do use our joysticks, because that way we'll have only one single issue, or one single direction that's not programmed. So right now the up arrow will let the ship move, and I think I messed that one up there. I don't think it's going to accelerate as it does so, but what it's going to do is check that the forward speed is less than 10. Remember, we initially set it to be 0. So for a while, the forward speed's going to just be changed by 1, so it will get, I guess, a little bit faster. But immediately after we pop out of this loop, what it's going to be doing is checking if the forward speed is greater than 0.1. So if we don't press the up arrow, we initially set our, let's see if I can find it, this speed to 0. What it's going to be doing, where is it? There we go. Regardless of if this up arrow is pressed, it's going to change the speed by negative 0.1. So if the up arrow is pressed, our speed's going to go up by 1, and regardless of whether or not it is pressed, it is going to decrease it just a little bit. I'm still trying to figure out exactly the purpose of that code. I think it's just so that it does start slowing down as time goes on in your game. But that's something I've still been working on, trying to think my way through. So, yeah. And forward speed does change a little bit more throughout the game as well, if I'm not mistaken. So this next little bit is going to give our ship the ability to fire, and this is where we'll be adding our button into the game a little bit later. In this first if statement here, the game is going to check a couple different things. It's going to check that the ship isn't already firing. So if there's already an active laser, then it can run this code. It's going to check if the ship isn't actively being hit, or actively with the hit Boolean variable being 0. And it's also going to check if the space bar is pressed, because that's going to be our final, hey, we want to fire, let's use that. So if all of these three things are true, the game will do a couple different things. It'll first change the firing Boolean variable to 1 so that it is true. and that will be used in just a second when we talk about the shoot broadcast. It will then identify the direction to shoot our laser, and I think that the direction is determined by, I think it's by our invader. I would need to double check that as well. And then it'll broadcast to our laser that it does need to be shot. There we go. So unlike in the Space Invaders game, the forward speed is not defined by just a wait time in between movements. It's actually defined in a more intuitive way by the amount of steps that it will take when an input is received from the player. So instead of it moving 10 steps and then having, a 0.1 second break in between them, it's just going to be given an input. It will move between 1 and 3 steps, which we'll see later. But just different ways to do it, I guess. But this way, the higher amount of steps will make the asteroids go faster, or your ship go faster for that matter, which is unlike Space Invaders, which had the smaller number would go faster. This is more intuitive, but that game as a whole I think is far more clever than Asteroids is. This is a very straightforward game. But anyway. So the game will move that amount of steps and will then store the ship's new coordinates in the variables ship X and ship Y. And it will always be updating these coordinates as as it moves, as the sloop continues running on and on and on. These variables will be used to fire and place our laser. Once these are set, it's going to wait just a short time to jump back into the loop, or before it jumps back into the loop to check to see if there are still lives. If there's not, or if there are, it's going to just go through the loop again. If there aren't any lives, we're going to say game over for 2 seconds, and then ask if we would like to play again. So if you remember, Space Invaders reinitialized the game a little bit differently. In that game, they broadcast back to one of the initialization broadcasts to restart it. I think it was the start game broadcast, which, if you all remember, is not the first. Was not the first of the broadcasts. There's many broadcasts that initialized that game, but the differences here is literally just different developers, different methods to get the same thing done. And you'll actually see that throughout this lesson. There's some stuff that was done differently than in Space Invaders, but still very valid to use. You're still more than welcome to do it the way that you are most comfortable with. And that's just how coding is. So let's go ahead and navigate over to our laser sprite. We're going to talk about that laser. Pew, pew! And I should probably get the obligatory laser cut before I go any farther. It's just going to be initiated by that broadcast from our ship that I think I showed you right up here. Where was I going? Alright, so our ship did set a variable called shot direction. And we're going to use this variable to direct our shot. So whatever angle that this is set to, that's the direction it's going to fire. Same as the point of our nose on our ship. It also is going to set the laser's initial position to the same as the ship's. And I've talked about this like 80 million times now. Why do we do this? Anyone can answer. Why do we set the laser's initial position to be at the ship? Yep, so it fires from the ship, so it shoots from the ship. Y'all got it. No surprises there. So now y'all can code games that have projectiles now. So yeah, that's exactly right. We also want to make sure that we show the laser. That seems like a good idea. We don't want any invisible lasers. Or maybe we do, that could be fun. But it's also going to be playing a laser sound. So in this repeat loop, it's going to repeat until the laser is touching the edge. It's going to just move 10 steps in that same direction. So until it hits the edge, it'll move wherever it is shot until it disappears. So that's when we hide it. Laser cut! I think of it every time. But then we set our firing boolean back to 0 so that we can continue on with the ship's movement loop that we discussed previously that can only be run when firing is set to 0. I don't even know where that laser cut thing came from. I think it was Daniel Donahue that did that. He would just always go, laser cut! Which would incite a cacophony of laser cuts from everybody else. Anyway. Here it also sets our laser to be initially hidden when the green flag is clicked. And ignore this asteroid thing. I meant to delete that and I did not. Because that's how I roll, apparently. So let's see where we're at. Okay. So just like we did in Space Invaders, we have multiple asteroid sprites that have pretty much... No, I think they do have the exact same code. So you can go navigate yourself to any of these asteroid sprites and take a quick look-ski at them. And by quick, I mean this is the most complex code in the whole game. Still pretty self-explanatory, fortunately. And luckily the first couple bits of this code is nothing that we have not seen a million times before. We always want it to be running, so we put it inside a forever loop. We switch to that very baseline costume, which is the one we want. Just like with the ship, there are 7 other different costumes that will be used to deal with an explosion. So they do that a little bit different than in Space Invaders. But then we would like to show the asteroid. And the movement of this asteroid is going to be a little bit randomized. They're going to set a new variable called side, which will be a random number between 1 and 4. The asteroid's final position there, or initial position rather, will be set by the following if statements. So, and there's 1 in 4 chance to get 1, 2, 3, or 4. So all these if statements below that deal with that. So if the code receives a 1, if the side is 1, the asteroid is going to start at the top of the screen. And we can tell that it will be at the top of the screen by this variable called start y. So start y is going to be 200. And if you all remember, I don't actually think I ever told you this, so never mind, you won't remember. Our game screen ranges from 200 to negative 200 in the y direction, so up and down, and then negative 250 to 250 in the x direction. So if we start our y position at its max, then we know that it's going to be starting at the top. But also notice that we have a random number to start our x position at. So not only are we going to be starting our asteroid at the top of the screen, it's going to start randomly positioned along the x-axis. So in this case, we pick a random number between negative 250 and 250 to have this guy start going. And so with a 2, it's going to be very similar to that. It's just going to start at the bottom of our screen. Notice start Y is negative 200, but continues keeping that pick random, negative 250 to 250 in the X direction. So it will start randomly somewhere along the bottom of our screen. So there's a couple issues with this, what was I saying? With this picture. So just give me 1 second to explain what's going on here. If the code does receive a 3, the asteroid is going to start at the left side of the screen, so at that X position of negative 250. And it will have a Y variable randomly, so like I said before, it'll start somewhere randomly along the left side of your screen. And the code is going to be the same for the right side of the screen, where we set our start X to be the far right side of the screen. But the big issue here is that instead of setting another start X, this should be start Y. So that's just a mistake in my slideshow. Sorry about that. I noticed it earlier and I didn't get time to fix it. So that should be start X as well. And that's how they give our initial position. So all that just to place an asteroid. But it does give the game an air of randomness so that we never actually know where the game will start. It's just going to be a crazy, sporadic thing every single time. But here's what I was talking about. It would move to this initial position. This is where we actually do that. It will then get set to point and move in a random direction. So this is going to be an angle. It's going to randomly move between 30 degrees and 60 degrees, no matter where it starts. And the speed is also going to be set to a random amount of steps, in this case between 1 and 3. You can make it harder by increasing this number. You can make it harder, or I'd say harder by increasing the amount of directions that it could go. But we want to set it so that it doesn't just immediately start going off of our screen. So that's why they picked 30 to 60. I think you can probably go anywhere between 0 and 90. And it should be okay. It'll definitely make sure that your asteroid does not just straight up go off the screen. But that's something you can definitely test. That's what's cool about Scratch. You can see what happens in real time. So the asteroid will then continue to move at the amount of steps it was randomly given. And if it's on the edge of the screen, it's going to bounce off of it. So note that this isn't contained inside a repeat until loop, so that it will always be happening until the laser cannon is touching the asteroid, or the asteroid hits the ship. I'm cutting out. Alright, let's see what I can do here. I've had awful internet access all day, so I don't have anything extra on. I guess I'm going to pause for a second here then. See if I can unplug and plug it back in, my headset. Any better? Okay. Let me know if that keeps happening, because I can't really tell from my end very well. Alright. So it's actually in the asteroid sprite. that will set what happens when the asteroid and the laser will collide. So just like before, we're going to increase our score, but this time we're going to quickly change and scroll through the asteroid's next 7 costumes, to give the illusion that the asteroid is actively exploding, so you can sort of see what the explosion looks like in real time-ish, just by changing the costumes real quick. So it gradually looks more exploded as time goes on, but that's a little different than what Space Invaders developer did. If you all remember, what he did was rapidly change the size of the costume to make it look like the explosion was getting bigger, as explosions tend to do, and then smaller. So, like I said, different ways to do the same thing. I don't think there's technically any difference except in processing power. The Space Invaders game probably has a little bit better processing power with the explosions, just because they don't have a million different sprites or a million different costumes to worry about. But you know, hey, it works, it works. You won't have to worry about that until you're in college and doing computer science, so they're both good options. Let's just put it that way. Now, if the asteroid did not get hit with the laser throughout all that code, and for some reason it's not hitting the sides, not bouncing off or anything funky like that, the only other option is that your asteroid hit the ship. So it's going to broadcast back to the ship, hey, you're hit, ha 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 ha, that's unfortunate. And just like this broadcast, we will now navigate back to our ship and take a look at the When I Receive Hit broadcast. So you'll notice that if you go over here, if you receive a hit, it's first going to check if you have any lives left. And if you don't, it's just going to skip this. It's going to go back into the previous player code that'll send you to game over, and then hit enter to restart. But this will happen if there are lives remaining. So if there are lives remaining, we're going to change our hit boolean variable to 1, so it's true. And also change our lives, again, by 1. Downwards, of course. -1, I suppose, is the word I'm looking for. And it's going to play some sad music because you lost some life. And just like with the asteroids, the ship will repeat through this loop, changing costumes very rapidly, so that it appears to be exploding. You're going to rename hit to, hey, you're hit, haha, that's unfortunate. You're more than welcome to do that. I just like to think of all our sprites as like people doing things. I don't know why, it just makes it makes the understanding make it easier for me, I guess. I don't know. But that would be really silly. Or to even change your sound effect to, hey, you're hit, haha, unfortunate. I think that'd be kind of silly too, but yeah. You died? Sounds like it hurt. This is when soundboards come in handy. I'm sure there's going to be some funny ones that y'all can create. So the next piece of code is going to let our ship pause before returning to its initial position at 0, 0. It's going to make sure our costume's correct. It's going to reset the hit boolean to 0 so that it's not hit. which again has effects in some of the other scripts. And it'll set our forward speed back to 0 so that it will make it not quite as fast as it was later in that specific life, I guess is the word I'm looking for. So anyways, I don't think there's very much more code in that regard. So what we're going to do, even if you don't have your joystick, is we're going to start actually adding some joystick controls to the game. You can still write the code in there and everything without a joystick. But I hope you'll remember how to hook up the joystick. And I'll give you specifics in just a second here. And hopefully you have enough female-to-female wires to do this. I know Raleigh got some in lab. You never learn how? You'll probably be doing that in lab if you haven't done this in lab yet. Or if you haven't, you know, done much coding at all in it. So if you're looking bird's eye view of your joystick, there's going to be 5 pins coming out of it. So first is going to be left, second's going to be right, third's going to be up, fourth's going to be down, and 5 is just going to be your ground. And your Raspberry Pi is able to be connected to this joystick if you hadn't guessed already. So just a quick review, very, very, very brief review. Each pin is numbered if you orient your Pi so that the SD card is pointed north and the USB ports are facing south. So you're looking at it from the top. SD card is going to be up here, USB ports. And you're going to count the pins from the upper left. So if here are your GPIO pins, the first pin is going to be the uppermost left pin. Okay, you couldn't hear me what I said? So to number your pins, you want to make sure your Raspberry Pi looks like this. USB ports on the bottom. Your SD card should be facing north. The first pin is going to be the top left pin. The last pin, which is pin 40, will be bottom right. So it's going to be a lot of information kind of quick. So bear with me here. To those of you that have done this in lab, if you remember the bit of confusion, or not confusion, but discrepancy in between the pin numbers and the GPIO numbers, here's where it comes into play pretty heavily here. So if I say GPIO and then a number, that's going to be, the GPIO number. If I say pin and then a number, that's going to be the corresponding pin onto your Raspberry Pi. Down on your joystick is going to be the fourth one, the second from the right. You can't get to your Pi because it's behind the TV, and that's totally fine. That's what the webinars are good for. If you can't do it at the moment, you can always do it later. So the first wire is going to go into pin 29. The next one will go right below it in pin 31. The next one will go right below that in pin 33. The next one will go right below that in pin 35. But the last wire will go into the very bottom left, which is a ground pin. So I do want you to raise your hand once you've gotten your joystick connected in that regard. Okay. Just a second or two more. But to those of you who know how to do your button, those are going to be, let me check real quick, I can't remember, pin 20 and pin 18. But I'll go over that in just a second as well. So I guess this is another raise your hand if you've got it, or raise your hand if you can't. Yes, I will go back up one slide here. Do you want this one or this one? That one? Okay. You got him? Okay. And hook up our buttons as well. Remember, buttons are not picky on how they're wired. They just need a ground and a signal input. We're just putting them in these two positions here, pin 20 and pin 18, since one is a ground and one is a GPIO pin. This is just for today too. If you've already messed with Space Invaders with this, they might have different pin numbers. That's fine. Just make sure that you fix it for all of them. Yeah, and I'll go back to the joystick real quick. I'll just sit here for a couple seconds. Sorry. I'm not trying to leave you behind. Yeah, just let me know whenever you're good to go. Oh, you're fine. It might help if you write them down real quick, too. And before we actually code it into the Asteroids game, we will be coding it into just a practice game first that we build. we good to continue? Okay, and you're all good. If those of you who have a little bit of experience with this want to just make a quick game with your cat sprite, just, make a new game, make sure your joystick's working with it, I'd highly recommend that. I will be giving you code for that in just a second, but we're just going to make sure that our joystick is working with it. Alright. And let me show you the button real quick too. One more time. Just plug in it into pin 20 and pin 18. But yeah, like I said, we're gonna make that little brief game to make sure everything's working okay. Gonna open up a new file, and can I show you the GPIO numbers for the joystick again? Yes. Or actually, well, no, I'll do it here. Wire can't reach the GPIO 24. Yeah, that'll be fine. Just make sure that your code reflects 23 instead of 24. So whenever it says GPIO 24, make sure you put down 23. We're not going to be using the other button for this game. Yeah, that's fine, Una. No problem. So I'm going to go ahead and move the code, or move over to the code thing now. Remember, this is going to be in a completely new game. We're just testing our joystick for now. I'll make this a little bit bigger so you can see it. And I'm going to be honest, I didn't make this, I didn't take these screenshots, and I'm a little bit hesitant on whether or not this code is correct. So definitely feel free to correct me if some big issue is looking wrong here. Actually, wait a second, hang on. I think I might have put my wrong thing in here. Maybe not. I'll see in a second anyway. So basically what we're doing, right when the green flag is clicked, is we're initializing all of our pins as inputs. We're first going to broadcast that our GPIO server is on by typing in GPIO server on into a broadcast window. Hang on, let me check something here. Okay. Looks like, I guess that's right. Looks like we haven't broadcast a button, or there's no button in here yet. But all we're doing is typing in config, the GPIO number, and then in. So we're going to do 4 different broadcasts. Config 5 in, config 6 in, config 13 in, and config 19 in. Yeah, you're definitely good to go if you already gotten a working game. I guess it goes to everybody, yeah. I know that different locations have had different lab experiences and everything, so. Yeah, no worries. One thing I didn't mention earlier is that if you try to work this game, before it will work, you need to go into Edit at the upper left side of your screen and make sure your GPIO server is on. If it says it's off, that means, or basically the way it says it is, if it is currently off, it'll tell you to turn it on. But if your GPIO server is on, the option in the edit menu will say turn it off. So if anyone gets to that point and is confused, I can help them out with that. But if anyone tries this code and gets it working, let me know what happens. Tell me what it's doing. I haven't been talking, that's why you can't hear anything. Yeah. I'm just waiting for y'all to get all this stuff in there. Tell me what's going on when you do get it working. Yeah. You got yours to work? So GPIO 5 is making it go left, 6 is making it go right, 13's making it go up, and 19's making it go down. Awesome. And all this code is right? The 0 is correct. Alright. I was a little bit confused because I got pretty confused during my lab session in Raleigh about that. So good. Good. Good to know. But if you got everything working, you are free to go. Even if you don't get it working by 5, A, you have the video, and B, I'll go over this briefly next class. But we still got a couple minutes before the good old 5 rolls around. The pin for the button is going to be, let me double check that actually, good point. It's going to be GPIO 24, which is pin 18. I did not include the pin in this, but you can definitely make sure that GPIO 24 is working as well. But you will have to configure 24 to be an input as well, up here in the broadcast area. So we're getting close to 5 o'clock. If you've got any questions for me, go ahead and ask them. If you're done working, you're free to leave. If you've got to leave, you can leave. And yeah. I appreciate y'all coming out today. As always. And no problem. Thanks for coming out. And farewell, Sam. And at that point, I will head out as well. So, thank you.